In this episode of KubeFM, I got a chance to speak to Paul Butler, who's the co-founder of Jamsocket. He's going to share his insights on leveraging key tools and making strategic decisions in cloud infrastructure. In this episode, we'll examine emerging projects in the cloud-native ecosystem that Paul is watching closely, including SleepDB, a REST-based key value store, and Caddy, an alternative approach to managing HTTP traffic. We'll also focus on Kubernetes, because at the end of the day, we found out about Paul about an article that he wrote called The Hater's Guide to Kubernetes. So we'll be exploring when Kubernetes is the right fit and when it might not be. Paul's perspective will resonate with anyone grappling with the balance between necessary and unnecessary complexity in cloud environments, as he shares his nuanced take on Kubernetes as both a robust technology and, at times, a challenging platform for rapid user-facing applications. This episode is brought to you by Syntasso, the creators of Kradix, a framework for building composable internal developer platforms. Kradix supports platform engineers in creating APIs and lifecycle management for platform components, acting as the intelligent glue between a portal and infrastructure as code. Kradix users can upgrade their backstage implementation from a portal to a platform and tame Terraform and crossplane code at scale. Visit them at syntasso.io. Now, let's check out the episode. So, Paul, to get started, what are 3 emerging cloud-native tools that you're keeping an eye on?
So one that came up very recently that I've been following kind of in the dark for a while and recently got open sourced is a project called SleepDB. And it's a key value store written in Rust on top of object storage, so S3, Google Cloud Storage, that kind of thing. I've been really excited by this idea of object storage kind of as this new, almost like networked file system. Obviously, it's not a file system, and I think that the things that kind of lean into the things that are different about it, the fact that you're not doing appends, you're kind of writing one object at a time, one blob at a time, that it's sort of becoming this new abstraction, even though it's been around almost 20 years now, that it feels like there's this resurgence of people doing things directly on Blob Store that I'm quite excited about. In a similar vein, distribution, a crappy name for a project, but CNCF project that does a Docker registry or container registry, OCI container registry. It's been around for a little bit, also backed by Blob Storage, or optionally at least. And I think it's just a great little project. We use it, and it seems intimidating to run a Docker registry, but with distribution, it's really not. It's fairly easy to spin up. You could even spin it up pretty easily in the Docker Compose and play around with it, upload containers directly from Docker, things like that. So I think it's just a neat little piece of software. And then the third piece of software that again's been around for a while, but I think I just like evangelizing about it, is Caddy. The Caddy server, we might get into a little bit how we use that in our cluster for a long time as an alternative to Ingress. And it's one of those pieces of software where they just make a lot of good decisions and have good defaults and kind of ease you into the complexity that if you want to, all of the knobs are there. But if you don't want it, it's just very easy to get started. And I love software like that.
Now, Paul, for the people who don't know you, what do you do and who do you work for?
Yeah, so I work for a company called Jamsocket. I'm a co-founder. We started it almost 3 years ago now. Essentially what we do is we provide infrastructure for applications, meaning cloud applications, to spin up processes on the fly. So it sounds a lot like Kubernetes, but what we do differently and what we're specialized in is we spin up processes that are web accessible. So every process has a host name that's accessible from the web. We do a little bit of security around that to make sure that you're not just kind of guessing these endpoints or anything like that. But the abstraction that we provide is basically you send an API call. You in advance, you upload a Docker container to us. So we have that ready. You send an API call and we send you back a host name that you can then connect to from a web client, a Electron app, a mobile app, anything like that. So, and we keep it alive for as long as the connection's alive, and then we shut it down. The kind of closest analogy that I like to use is it's kind of like Amazon Lambda, except instead of spinning up your function on every kind of request and response cycle, we're keeping it alive for a longer bidirectional connection, which could be minutes to hours. And then usually the user closing the tab, and a web app is usually what triggers it. When the connection's dropped, we shut that process back down. So we manage the whole life cycle.
And how did you get into cloud native?
So my career, I kind of straddled like data science and data engineering roles throughout my career. I worked at Google for a bit, so I had a little bit of exposure to Borg, mostly just as an internal consumer. Honestly, was a little afraid of it at the time. It's big, scary cloud configuration where I just want to run a simple app kind of thing. So I had a little bit of exposure to that. Went into finance, so I was on a research team in finance for about 5 years. And so doing less kind of hands-on engineering, but I kept the engineering side going by building a lot of my own tools. So if I wanted to build a tool to analyze lots of data, I'd build that. What I found throughout my career is that anytime I wanted to deal with build tools that dealt with lots of data, I kind of realized that there was this gap in the infrastructure where it was really easy to build that if it's sort of just like a local running app can scoop up tens of gigabytes of data on a beefy workstation and have no problem with it. But increasingly people wanted these tools, including myself, I wanted these tools to run in the browser. And the browser is just like fundamentally limited. So you need to kind of lean on the cloud more to do that compute and load that data. And the traditional stateless server architecture also just wasn't a good fit for that. You can't really have a Flask app load in 10 gigabytes of data for every user. It's just not architected that way. So I realized that there was this missing piece that kind of looked like Kubernetes. And so that was what attracted me to Kubernetes at first. We ended up kind of writing this as its own distributed system, so not directly on Kubernetes. But because of that exposure to Kubernetes, we decided that we wanted to keep running the control plane on Kubernetes. So we run a lot of our internal services on Kubernetes. We use Kubernetes pretty heavily internally.
And with being users of Kubernetes on a regular basis, how do you stay up to date with all the changes going on in Kubernetes, and further from that, the cloud native ecosystem?
So I think we take a pretty boring approach to Kubernetes in the sense of the sort of software should be boring manifesto, where most of what we use is kind of the stable features that have been around for a while. So we're not really on the cutting edge of Kubernetes. One thing we do is we have a Slack channel that we get all of the change logs from, at least from Google Kubernetes engine, and I believe some Kubernetes change logs as well, so that we sort of see version by version, especially if there's vulnerability or something like that that's been patched, so we can be sure to kick off the upgrade on our systems. But for the most part, it's really just Twitter and Hacker News. If something comes on my feed about Kubernetes, I do tend to keep an eye on it.
And if you had to go back in time and give your previous self one career tip, what would it be and why?
So one thing I've noticed about software development is that no matter what I've done, from kind of the data engineering world, data science, infrastructure world, I've dabbled in the web a bit. I think that the through line, like the kind of meta technique that's sort of there across all software is that if you can separate the kind of necessary complexity from the unnecessary complexity and then build abstractions over the unnecessary complexity, I think you can really advance what you can do, what you're capable of So I think the meta skill that's the most important there is being able to identify whether complexity is necessary or not. And so I don't have like direct advice on how you build that skill, but I think that if you start noticing that early in your career, that you can build that skill over time and be a very productive software engineer.
For our monthly content discovery, we found an article that you wrote titled, and yes, this is the title, The Hater's Guide to Kubernetes. The following questions are designed to take this topic a little bit further. So just to get things started, we want to, go right into the hot take. You said in 2022, although I must add that before we get started, there is an addendum that we'll mention at the end. There is an update to this blog. But in 2022, you said, I might gripe about Kubernetes sometimes, but it really is a great piece of technology. I highly recommend it to all my competitors. I imagine there's a lot to unpack here. Is Kubernetes really a great piece of technology?
So yeah, the funny thing about that is that like I think there's sort of three statements in there. There's, Kubernetes is a great piece of technology. I recommend it to my competitors. Maybe it was just the two. There's two pieces, but I do sincerely believe both of those. I think that Kubernetes is a great piece of technology. I think the fundamental, like the core of it, the core idea of Kubernetes, as I kind of explain it, is you have control loops where you kind of have this, this descriptive version of the world of this is what I want to exist in my deployment, and then control loops that make it happen, and cycles of control loops and kind of recursive control loops and that kind of thing become this really powerful but also fairly grokkable abstraction, and just super robust, right? Control loops by their nature are very robust because if something breaks, the control loop is kind of sort of self-healing. And then Kubernetes takes that control loops idea and puts it on top of Raft consensus, which is in itself also self-healing and very robust. And just in combination, you get these, you kind of combine these two abstractions and get a super powerful mechanism for making robust systems. So the first part of the statement, absolutely true. Like, I think it's a great piece of technology. Where the recommending it to my competitors snark comes in is that, the nature of what we do is, as I've explained, is sort of spinning up lots and lots of these processes. Part of what we do, we tend to expect that a human being is waiting on that process to start. And one of the things that I've sort of started to believe over time and become increasingly confident in is that I think Kubernetes is the wrong tool when a human being is waiting on a pod to start. I think that that's a big anti-pattern that I've seen. So when I say that I recommend it to my competitors, I do think that if we have competitors who are also starting processes on behalf of users and they're basing that on Kubernetes and they've got a human in the loop waiting for a pod to start, I'm less concerned about them because I think that they're going to run into the same pitfalls that we did, because we started that way. We actually did start running all these, all these processes on Kubernetes initially. But we kind of found that it was easier to bite the bullet and abstract away all of that into our own systems than it would have been to kind of shape Kubernetes to our will.
Now, an adjective that we find being used to describe Kubernetes quite frequently is complex. And, this year celebrating 10 years of Kubernetes. In KubeFM, we interviewed over, 24 ambassadors about CNCF ambassadors about what they hope for the future for Kubernetes. And a lot of them referred to what you said about becoming more boring or reduced complexity. In another article that you wrote, you talk about accidental versus essential or necessary complexity. Can you walk us through what you mean by necessary complexity and how it relates to Kubernetes?
Yeah, so I think this is in some ways just a fancy way of saying you should use the right tool for the job. But the analogy that I like there is, you probably all have a microwave. Every microwave these days has a timer built into it. If you think about that, kind of the user interface to that timer and the state space of all of the possible states that could be in, and if you were to kind of map out the finite state machine of all those states, you get this pretty complex chart that is complex for a timer. And then, if I'm ever in an Airbnb and I'm using the microwave, usually it's not immediately clear to me. It might take a few button presses before I figure out how to set the timer, versus something like an egg timer, dial timer, where you can kind of twist the timer. So if you're using a microwave to heat food, you need all that state space, right, of the complex microwave UI. But if you're using it as a timer, you just need the dial. And I think that seems very obvious when I'm talking about a microwave and a timer, but I think that in software, we kind of skip over that sometimes, especially when software seems magical, right? Like what Kubernetes is doing, when it's starting containers and all that, if you kind of don't know the underlying pieces that make that work, it can seem magical. And then you see that magic and you just you're willing to deal with a lot of complexity to get that. Where I think in a lot of cases, the things that people are using tools for are not that magical, and there's sort of simpler abstractions that would work. Maybe those better abstracted tools exist, or maybe they should exist, but I'm encouraging people to either go find them or go build them.
And if the perception is that Kubernetes is hard, which seems to be fairly widespread, but we can't simplify it further due to necessary complexity, how do other technologies, get away with that? If we think of the example of Heroku, how is it just so much easier to use Heroku?
I think one of the things that makes the sort of essential complexity in Kubernetes is that there's always going to be this trade-off between this sort of resilient control loop system, which, if it fails to start a pod, it's going to try again, and it's going to keep trying that. The flip side of that is that it makes feedback loops longer and more complex, right? Like you can do a kubectl apply, and you've created that pod. So it looks to you like you've been successful, and it's just in the background that failure is happening. And I think that resilience to failure and feedback loops can almost be kind of at odds with each other as goals in software. So I think that that's part of it. I think also just that software that kind of has a web UI, state becomes very discoverable when you have a good web UI. And I think that that's why software like Heroku and Railway and Google Cloud Run and some of these other softwares that are sort of either abstractions on Kubernetes or kind of equivalents to Kubernetes or equivalents to various opinionated pieces of Kubernetes, where they can kind of do better is because they do have that very highly discoverable UI, short feedback loops, that sort of thing.
So with this in mind, when should someone choose Heroku or Kubernetes? Or beyond that, why should anyone use Kubernetes at all?
So we kind of narrowed down to 3 reasons why I think Kubernetes is right for us. One is, we want to run a number of services. We kind of want to treat it as an abstraction over a bunch of machines, where instead of saying, I want this job to run on this machine, I can kind of have a pool of machines, a pool of jobs, and Kubernetes sorts out what runs where. Another thing is that we want to control it as code. Like, I really am big on infrastructure as code. I think it's just the right approach, and Kubernetes lends itself really well to that because it itself is configured through code. And then the other thing is, I think that one of the advantages that we get out of Kubernetes is some of the resilience, both in terms of if a node goes down, we can have redundancy, but also when we're doing a deploy, it'll do the right thing. It'll keep services running until the new services are up, things like that. So I think really the value of Kubernetes as a small company like ourselves is in the intersection of those 3 things. And despite the article being the hater's guide to Kubernetes, I think the guide to Kubernetes part is kind of important too. It's the article is sort of a description of what has worked for us in terms of what we have and what we did and didn't use of Kubernetes to make it work for us at our scale. So even though it's the hater's guide, like, it's ultimately we are using Kubernetes, and it is a guide to using Kubernetes, not just a guide to hating Kubernetes.
A very important clarification, so folks don't get misled out there. On the flip side of all this, though, when should you know when to use Kubernetes? I mean, keep this in mind. I was part of the Data on Kubernetes community for 3 years, so don't hurt my feelings by saying databases or some kind of stateful workloads. But how would you answer that?
Yeah, so my take on data, so one of the things I talk about in the article is that we don't store state in Kubernetes, which is not to say that that's never good or never at scale. For us, one of the reasons that we do that is that as far as kind of, I think once you for as long as you can treat Kubernetes as stateless itself, the cluster itself as stateless and the state living outside of Kubernetes, it is this really nice abstraction and it's really nice assumption that you can use, both in terms of day-to-day management, but especially if something goes wrong, it is really nice to not be thinking about, if I destroy this service, am I destroying state? It's kind of like, I like kind of being able to say, okay, I'm just going to knock this over and it's going to write itself and we'll be back. We also ran into there's some foot guns when you start dealing with stateful-sets. Can kind of cause deadlocks and things like that. It's obviously people do it and there's ways around it, but until you've kind of hit those foot guns in an emergency and kind of worked through that, there's dragons out there. So what we found is that, as I mentioned up top, like I love blob storage. I think it's like a brilliant abstraction that we should all be using more of, and I'm very excited to see that. I think that's being embraced a lot. And then we also use a traditional relational database. We use Postgres, but I love that we can just outsource that to Google. We're running on Google Kubernetes engine, and then we run Postgres on their Google Cloud SQL. They do a great job of keeping it up, better than we would do without us having to think about it at all. So, and then we get a bunch of nice things on top of it. So, I think it comes down to my preference to just outsource that stuff if I can to a company that knows how to run it and knows how to coordinate the backups and gives me a nice UI, because at the end of the day, like things that are stateful, I just sleep better at night if I know that those are in good hands, even if it costs a little bit more.
Fair points. Now, it's no secret that Kubernetes has a vast number of features that cover many different use cases. Its inherent complexity partially comes from the fact that it's standardizing and exposing all those features, giving you the chance to tune all possible knobs. You clearly have strong opinions on when not to use Kubernetes, but do you also extend to Kubernetes resources like pods, deployments, and stateful-sets?
Yeah, and in fact, in the article, one of the things that I kind of the value that I try to provide in the article, and really the article is like what I wish existed when I started dabbling in Kubernetes, which is sort of I don't want to say a blessed path, because that makes me sound like I know better than anybody else, but I do think that there's certain resource types and certain paths have a higher level of difficulty in Kubernetes. And I think there's just this really happy path where if you're using, if you're mainly sticking to deployments, services, and, ConfigMaps and secrets and cron jobs, kind of the bread and butter resource types that are really well supported across clouds, that are not interfacing much with the clouds. Like they're kind of just, you're just kind of running a job. It's all pretty standard vanilla stuff, that if you can stick to that as much as possible, and there's exceptions, and I do talk about, when we make exceptions for those things, but that along that happy path, you can be very happy and you don't have to, go headfirst into all of the complexity of Kubernetes.
Reading your article, there was another statement that stood out quite a bit that I think will make some of our audience members go as far as, rethink their lives. You actively avoid RBAC resources such as roles and role bindings. Why is that?
Yeah, so I think I put those in the cautiously used category, because we do use a little bit. For example, and we can talk about this as well. We don't use Cert Manager. We have our own job that essentially it's just a single process, no CRDs or anything like that. We just configure on the command line, and it fetches certificates for us and then stores them in secrets. So it needs to do some RBAC. So things like that, we will occasionally use RBAC for, but I just found, so for context too, we're a team of 4. We use basically GKE access itself to, like Google Cloud, to gate access to the cluster. So there's some IAM there. We could make it more fine-grained with RBAC. We just haven't had a need to yet. So really, we only use RBAC for giving deployments themselves, pods themselves, access to Kubernetes resources. But in general, I just have found that it's going back to the statelessness, it's just a really nice assumption if you can assume that for the most part, deployments are not interacting with the Kubernetes control plane. Like you kind of separate the application and data and control as much as possible for as long as possible. It just makes things nicer to manage. There's I think, a point of scale where you need RBAC for users for sure, but also probably want to do more interacting with the Kubernetes runtime. But yeah, it's just I think the happy path is avoiding that as much as possible.
Are there any other things that you categorically do not use in your clusters?
Yeah, we've avoided operators in general, so CRDs and operators. There was a point where we went all in on that. We were writing our own CRDs and our own operator. Our whole system itself was a Kubernetes operator. We found that there were just enough foot guns with that. Then it wasn't actually buying us that much. And it meant that we were, in our case, we were very focused on, we want fast start times. We want things to happen quick in our cluster, even at the expense of, the 1 in 1,000 cases that fail. Like if we have a failure case, we can retry it, but we're not optimizing for that case. So what we found was that, for one thing, anything that goes through CRDs, you're going through raft consensus at least once, possibly multiple times. And, that does add up. It doesn't add up to that much if you're just starting a service that runs for 72 days. But if you're running a service that goes for 15 minutes and has a human being waiting for it to start, it does create noticeable latency to kind of have to go through etcd and kind of go through raft consensus a number of times. So, we found that we moved ourselves off of operators, and then we found that other things that used operators were also, even if they weren't in that critical path, were just slow and had a long feedback loop and were kind of not the right fit for us. So we ended up, instead of Cert Manager, we started using Caddy, which can fetch its own certs. We also wrote our own tool for fetching certs with like Acme DNS01 for things that we couldn't put Caddy in front of, kind of non-HTTP services. And that sounds hard, but it was like a couple hundred lines of Rust. We'd already been working on a library for that for some other things, so we kind of had that available. So things like that, where like piece by piece we could kind of replace these operators with fairly little code. Another thing we don't use is Helm. I don't like templating code in general. I kind of grew up, one of my first languages was PHP. I thought we learned back then that string templating was not a good way to do code generation. Even something like the evolution between PHP and React, where people are doing like JSX, where it's sort of syntactical validity is ensured. I feel like is a better approach, and I'm kind of disappointed that Kubernetes has gone so all in on string templating for that. Especially with YAML, I'm not a huge fan of YAML to begin with. So the Helm ecosystem, I've just tended to avoid. What we've often done, for the most part, we're running code that we've written on our cluster. We're not running a lot of external software anyway, but on the occasional time that something does come as a Helm file with a number of pieces, what we've done is kind of deconstruct that Helm file and really, it's time consuming, but it also gets us to understand what that Helm is actually doing and how things are coordinated and what pieces we actually need.
Okay. Just to take it a little bit further, we did have a previous podcast guest who very much agreed with what you said, that Helm's design was fundamentally flawed in a similar way, to use the example of PHP. But I do want to take the point about CRDs further, because we've heard from several guests that that's their favorite feature on Kubernetes. If you could maybe walk us through a little bit about how you see, the control loop inside the operator, or perhaps additional downsides that you don't think make, CRDs worth using.
Yeah. So I think there's like, going back to the kind of incidental and essential complexity, I think there's a bit of both with CRDs. I remember one of the things that bit us was just the running into like size limits on how big the CRD definition can be, because it all has to fit into etcd, and kind of some of the things that are really more design decisions than kind of essential complexity, but that made it, none of it was insurmountable, but it was kind of a series of foot guns where we're kind of just like, okay, at some point, what are we gaining from this that's sort of worth the cost of all the foot guns we're dealing with for it. And then there's kind of the essential complexity, which gets back to the kind of the slower feedback loops, which for a lot of things you just want. One of the things I talk about in that same article is the analogy of kind of a thermostat versus a on-off switch on a heater, where if you have a heater, you hit the on-off switch, you know immediately if it's broken or if it's working, whether air starts coming out. Whereas if you have a system on a thermostat, you might set the thermostat and nothing happens, which it shouldn't. But you don't know if the thermostat is broken, if it's just taking time to kick in, if the thermostat is working, but the system downstream of it is broken. So it's just a number of more moving pieces. Now, what you get for those moving pieces is great, which is that you set the temperature and then you never have to think about it again. Or you never have to think about actively turning that switch on and off. So I think when it comes to that essential complexity, there really is value there. And going back to what I said at the beginning, I think the idea of kind of having this genericized kind of resource on a control loop, on Raft, if that's what you need for a system, then I think Kubernetes executes that brilliantly, and it's very high quality piece of software if that's the actual need. But I think what happens is people sort of see that and say, okay, this is going to be the only, this, it's kind of like if all you have is a hammer type situation, where I think for us, Cert Manager was more complex than it needed to be. What we needed was just a for loop with a timeout that would write a certificate and private key to a secret. And so that's what we built, and it's been a lot easier to manage than having to think about CRDs.
We have another guest, Ori, who talked about, his opinions about network policies, saying that he didn't feel that they were the right abstractions. However, he didn't go so far as to say that he thinks it's a good idea to ban them. I guess there's a time and place for everything, but the goal is to minimize complexity whenever possible. Would you consider that to be a fair summary of how you're thinking about it?
Yeah, I think that's right. I think we're trying to minimize complexity. My post, the way I frame my post as well is it actually did start as we had a new hire join, and I wanted to kind of document some of the internal wisdom we'd gained on kind of what did and didn't work in Kubernetes for us and why. So that it wasn't just sort of arbitrary, we don't use ingress or we don't use that, or that it was kind of, why we've gone, what foot guns we've hit, that kind of thing. So I didn't intend to initially write it to kind of be prescriptive to other people and say you shouldn't do this, you shouldn't do that. But I did realize as I was writing it that I was well, this would have been very helpful for me a couple of years ago. So I decided to do it as a public blog post instead. But, not framing it as these parts of Kubernetes are bad. Obviously, everything that was put into Kubernetes was put in by somebody for a reason. And so I think that, I don't mean to be dismissive at all of those reasons, but it's some of those reasons exist at a Fortune 500 company. Some of those are not relevant to a 4-person startup. And I actually wanted to combat, there's a lot of people out there who say a 4-person startup just shouldn't be using Kubernetes. It's not built for you. It's not built for your scale. My point was actually we can be very productive with Kubernetes. It's just a matter of kind of understanding where the happy paths are and where there's dragons.
At the beginning of our conversation, you said Kubernetes is great for running multiple processes, running them redundantly, and thirdly, describing their relationship in code. What would you suggest to someone who doesn't have to run multiple processes or need redundancy?
So I think for a lot of startups, especially companies just sort of doing a traditional SaaS kind of web application with a database, I think if I were doing that, I would look first at all of the infrastructure providers that are kind of providing a layer of abstraction above something like Kubernetes. My go-to is actually Google Cloud Run for this. I think it's a fantastic product that's actually not talked about that much among these products. I think that when people think serverless, they think function as a service and Lambda. But where I think the sweet spot is with serverless is I never want to think about scaling services, but I do want to be able to write a traditional server. I think that, there's advantages of being able to just run that server anywhere. There's some portability. So I think Cloud Run hits that abstraction very well, where you provide them a server, they'll scale down to one and scale up as much as you need, put it behind a load balancer. If all you're doing is a stateless service, that works very well. There's also some upstarts like Render and Railway. There's companies that will kind of do this on your cluster on Kubernetes, like Flight Control, a few others that I'm blanking on. But there's sort of a big ecosystem of companies that want to help you out if you're just a SaaS trying to serve a traditional vanilla web app with a database, that until you actually need a bunch of services talking to each other or doing funny things like integrating Docker registry like we do and things like that you probably don't need to go all the way to Kubernetes from day one.
We've now made it to the point where we get to hear from you about the update, the addendum to the post. And in addition, now that we know the whole story more or less, I just can't help but ask, do you still recommend Kubernetes to all of your competitors?
Yeah, so I think both the points there, both the sincere point about Kubernetes being an excellent piece of software, and that I do hope our competitors in the specific space we're in use it. I think those both do hold. The addendum that you referenced, so one of the things I wrote in the original post was that we don't use ingress resources. We use, essentially we stick Caddy in front of a load balancer. So I actually stand by that recommendation. We did it for several years and it worked great for us. I got some pushback on that from people in comments and things. So to clarify what we're doing is like, we're running a Caddy server for every deployment. What we're doing is sort of writing a Caddy server that's configured like you would configure an ingress, where Caddy can support multiple domains and obtain certificates for them automatically, and it's quite nice that way. So that's how we were using Caddy, and still are to some extent using Caddy. But what happened was we realized we wanted to use a Google product called Google Cloud Armor that it does rate limiting and some other kind of checks. You can kind of think of it as Google's Cloudflare type product. So that just integrates really well with Ingress. So we did end up doing a migration a couple months back that migrated many of our Caddy routes to Ingress. I'm still hesitant to recommend Ingress. I mean, for one thing, it's kind of being replaced by the new API. I think they call it API Gateway. There's a new, so to us, it was actually nice to hear that they're not going to be doing any more work on Ingress, because it was like, well, it's done, but it is kind of deprecated in favor of that. So, but it's worked for us, and the integration, the migration was not too painful. So I would still recommend, unless you already are familiar with Ingress, if you are familiar with Nginx or Caddy, use Nginx or Caddy to begin with, and then you can always migrate to Ingress later.
In terms of our closing questions, the first one I'm excited to ask. You are the founder of Jamsocket, but after reading your bio, I discovered that you created interactive reports on ranked ballot election results, a browser extension for exploring branching conversations, developed interactive essays on the Mandelbrot fractal, how to size bets, and the mathematical nuance of American elections. We're getting close to one. We can probably talk about that. And last but certainly not least, written code notebooks for forensic video analysis, Lindenmayer fractals, optimizing pen plot routes, and generating pseudo 3D line graphics. Do you sleep, and what motivates you to keep creating?
Yeah, so I do sleep. I find I increasingly care about work-life balance, and I'm able to achieve it. I think one of the things that's helped at being being somewhat prolific, I guess, in my content, which I didn't think of myself as until you kind of list it all. But, just having been around the internet for a while and kind of consistently pushed things to a place where they stick around. So things that I've done at this point, well over a decade ago, can still be found. So I think just the accumulation over a decade plus has helped kind of make it seem like I do a lot. Yeah.
What motivates you?
So I'm really interested in kind of tools that help people create, but also to explore and explain things. I think one of the things I really liked and I almost miss about data science and that work is just the ability of computers to kind of amplify your curiosity and satisfy your curiosity, especially around, taking a gigantic data set and asking questions of it and being able to kind of drill down. A lot of the projects you mentioned are kind of interactive data essays, which is probably my favorite genre. I think sort of having some sort of a prescriptive path through data, but at the same time giving people the toggles and the ability to kind of explore on their own and make their own conclusions, I find really interesting.
What's next for you?
So Jamsocket is pretty much my 24/7 what's on my mind these days as a startup. So doing a lot of internal work to kind of keep going and make us, I think of it as kind of even the things that people would compare us to Kubernetes for. Like we want to use the fact that we're a very opinionated stack to like go further in the direction of doing things you couldn't do as easily with Kubernetes. So our focus has really been on focusing on cold starts and some of the authentication stuff, some of the stuff we can do when everything is all networked together, or we've kind of vertically integrated the networking and the all the way to layer 7 and the containers and all that. So we've got a lot of exciting stuff that way. We also, I should mention, the core of what we do is open source as a project called Plane, which is at plane.dev. So we're continuing to kind of build things in public that way.
Very good. And if people want to get in touch with you, what's the best way to do so?
So I'm on Twitter or X as Paul GB. I write a newsletter called Browser Tech Digest. It's a little bit of a hiatus over the summer, but that is digest.browsertech.com. We also do some events under Browser Tech, and I guess to briefly explain that, is basically I think of Browser Tech as all of the new surface area of the browser APIs, things like WebGPU, WebAssembly, to the extent that people are kind of doing stuff in the browser with those technologies. WebSockets are a big one for us. So I do those things. I'm on LinkedIn as well as Paul GB. And if you want to email me, it's paul@jamsocket.com.
Fantastic. Paul, thank you very much for joining us today here at KubeFM. Look forward to see what you're doing next. See if that hater's guide to Kubernetes might get another addendum. Thanks a lot.
Thank you, Brett. It was my pleasure.
Cheers.